everyone, and welcome back. In our journey through the foundational concepts of data mining, we've talked about what data mining is and the kind of knowledge we can discover. But before we can run any algorithms or build any models, we have to talk about the most fundamental element of all, the data itself. This is section 1.5, where we'll explore the different types of data for mining. Think of this as learning to identify your raw materials before you start building. By the end of this section, we're going to achieve several key things. First, we'll understand that data isn't a monolithic thing, it comes in a vast array of formats. We'll learn to distinguish between the primary structures of data, structured, semi-structured, and unstructured. We'll also dive into the classic statistical way of classifying data by its measurement scale: nominal, ordinal, interval, and ratio. Finally, we'll touch on the difference between static and streaming data. By the end, you'll recognize that understanding your data type isn't just a box-ticking exercise, it's an absolutely essential first step that dictates everything that follows, from preprocessing to analysis. So, why does all of this matter? Imagine you're a master carpenter. You wouldn't use a sledgehammer to set a tiny finishing nail, and you wouldn't use a handsaw to cut a steel pipe. Data is our raw material, and just like in carpentry, the tools and techniques we use must be suited to the material at hand. Different data types require different algorithms. Some algorithms only work with numbers, others can handle categories. The way we clean and prepare the data, what we call preprocessing, varies dramatically depending on its structure. And finally, how we interpret our results, what a pattern even means, depends entirely on the type of data we started with. So, knowing your data is the first and most critical step. To make this manageable, we can categorize data in two main, interconnected ways. Think of these as two different lenses for looking at your data. The first lens is by structure. How is the data organized? Is it neatly arranged in a table, or is it a messy collection of text and images? The second lens is by its measurement scale. What kind of information do the values themselves convey? Are they just labels, or are they meaningful numbers? We'll explore both of these perspectives in detail. Let's start with the first lens, structure. The most familiar type is structured data. This is the epitome of organization. It's highly organized, typically in rows and columns, where every row is a record and every column is a specific attribute. This is what you find in SQL databases, Excel spreadsheets, and CSV files. Because of its rigid format, it's very easy for machines to parse and process. Consequently, it's the type of data used by most of the classical, foundational data mining algorithms you'll learn about, like regression and decision trees. On the complete opposite end of the spectrum, we have unstructured data. As the name suggests, this data has no predefined format or schema. It's the Wild West of data. Think about the text in a book or an email, a photo on your phone, an audio recording, or a video file. This type of data is incredibly rich in information, but it's also far more challenging for computers to understand directly. To mine insights from unstructured data, we need specialized techniques like natural language processing, or NLP, for text, and deep learning models like convolutional neural networks for images and video. Sitting neatly in the middle, we have semi-structured data. This data doesn't conform to a rigid table structure, but it does contain tags, markers, or hierarchical elements to separate data fields and create some level of order. It's self-describing. The most common examples you'll encounter are JSON, which is ubiquitous in web applications, and XML. Even an email is a great example. It has structured parts like the to, from, and subject fields, but the body of the email is unstructured text. This type of data is very common when pulling data from API or for web data integration. Now, let's switch to our second lens, the measurement scale. This is a concept that comes from statistics, and it's crucial for understanding what a number in your dataset actually represents. We can broadly split these scales into two groups. First, categorical or qualitative data, which describes qualities or categories. This includes nominal and ordinal scales. Second, we have numerical or quantitative data, which represents measurable quantities. This includes interval and ratio scales. The scale of measurement determines what mathematical and statistical operations are actually valid for that data. You know, as I was preparing this section on the KDD process, I kept thinking steps 1 through 4. That's where most data projects go to die. The cleaning, the integrating, the transforming, it's essential, but it kills momentum. So I want 90 seconds to tell you about a tool that's been a game changer in my workflow. It's called Finot. Think of it as an end-to-end analytics platform that's completely browser-based. You know Power BI and Tableau? Finot is in that family, but with a powerful twist. Here's what makes it different. On a visual canvas, you drag and drop components to build your entire data pipeline. Bring in data from Excel, CSVs, JSON, or connect directly to databases. Finot automatically creates PostgreSQL foreign tables from your files so you can query everything with SQL instantly. Then, right on that same canvas, you apply transformations, run aggregations, and generate beautiful visualizations, bar charts, line graphs, box plots. You never leave the platform. Think of it as Tableau's visualization power combined with the workflow capabilities of a data integration tool all in one place. Everything autosaves, so you never lose work. Whether you're an analyst, a scientist, or just love exploring data, Finot helps you spend less time wrestling with code and more time discovering insights. It's open source. Check the link in the description at github.com/devo/finot to get started today. Alright, back to the tutorial. Thanks. The first and simplest scale is nominal data. Nominal comes from the Latin word for name. These are used purely as labels or names to categorize data. There is absolutely no intrinsic order or ranking. A classic example is a customer ID number. Even though it's a number, customer 100 isn't greater than customer 99 in any meaningful way. Other examples are marital status, gender, or product category. Because there's no order, the only mathematical operation that makes sense is counting. We can count how many customers are in each category. Next is ordinal data. Here, the categories do have a meaningful order or ranking. However, the intervals between the categories are not equal or known. Think of a satisfaction survey with ratings like satisfied, neutral, and dissatisfied. We know satisfied is better than neutral, but we can't say it's exactly twice as good. Other examples are education levels: high school, bachelor. Moving into numerical data, we have interval data. This is numeric data where the difference between values is meaningful and equal, but there is no true, meaningful 0 point. The classic example is temperature in Celsius or Fahrenheit. The difference between 10 degrees and 20 degrees is the same as the difference between 20 degrees and 30 degrees. However, 0 degrees doesn't mean no temperature, it's just an arbitrary point on the scale. Because of this, you can meaningfully add and subtract values, but ratios are not valid. You cannot say that 20 degrees is twice as hot as 10 degrees. Finally, we have ratio data. This is the most powerful and informative data scale. It has all the features of interval data, equal intervals, but with the crucial addition of a true, meaningful 0 point. This 0 indicates the absence of the property being measured. Examples include age, height, weight, income, and number of purchases. Because a true 0 exists, all mathematical operations are valid. You can add, subtract, multiply, and divide. You can meaningfully say that someone who is 40 years old is twice as old as someone who is 20. So, to quickly summarize our measurement scales, nominal is categorical with no order. Ordinal is ordered categories. Interval is numeric with meaningful differences but no true 0. And ratio is numeric with a true 0, allowing for the full range of mathematical operations. Beyond structure and scale, there are a couple of other important distinctions, especially when we think about the context of the data. Static data is what we typically think of. It's stored finite, like a historical database table. We can analyze it repeatedly. In contrast, streaming data is continuously generated in real time from sources like sensors, social media feeds, or financial tickers. Now, let's tie this all back to data mining. Here's why every distinction we've discussed today is so critical. First, the type of data you have will determine which mining techniques you can even consider. Second, your preprocessing steps handling missing values, normalization, are dictated by data types. You wouldn't average missing values for a nominal category. Third, many algorithms or methods. Let's leave this section with these key takeaways firmly in mind. The type of data you're working with is the single most important factor in determining how it can and should be processed and analyzed. We categorize data primarily by its structured, semi-structured, and unstructured, and by its measurement scale: nominal, ordinal, interval, and ratio. Mastering these concepts isn't just theoretical, it's the essential prerequisite to performing any successful and meaningful data mining project.